I'm recording all this content, but Zoom actually takes like 5 hours for it to process and create that video in a compressed format. So after the class, I have to wait for like this thing, and sometimes in the middle, if the computer reboots, you have to then go find where it made the half processed file and start. That's why last time I think I couldn't send the video immediately, but I'll make it a point to like send it as soon as it's finished the conversions so that you can refer to it. So having said that, any more questions from last class?
Yes, I like one. I mean, it's not from the last class, but from the project management perspective, right? Can we also know the check-in, check-out process and few things how the project uh, is maintained?
Check-in, check-out process.
Yeah.
As
So,
in, what do you mean
like,
by that?
I mean, version control of my code, and then the
Oh,
compilations if required. I know
so
that. Yeah.
so I don't think we are covering that in this, but if you want, I can give you a brief dump of Git, like how Git works and like what are the commands in Git repository. Like nowadays, like the most, so there are like different version controls, which we require for like in general, like where you actually, it's mainly because if multiple people are working on the same project, there are different like controls, like TFS is one version control, Source Depot is one version control, and Git is the latest one, which is open source and it's being very popular. So right now, this is basically we're doing like different projects for different thing, but I think it will be a good group exercise if for us, like anyone who knows Git, like I know we have some college students also. Meher, do you know Git?
Yeah, no, I know Git.
So why don't you actually? I mean, I'm volunteering you to like
Sure.
create a public Git project.
Okay.
And then we will all the projects which we'll do here.
Yeah.
We'll put it there.
Okay.
And,
so I'll just create the repo, and will you send me the files that you want on
I'll
that
send
repo?
you the files, and then
Okay.
we can then sync, and we
Yeah.
can and then like assignment questions you guys can like upload and like make your own branches and upload it there. So it'll be good to learn. I can show you like main Git commands, Raghav, like how we check out the project, how we switch branches. The thing is, Git is a little difficult to follow if you have never used it. It uses something called as like the way it updates it and stuff is a little different than Source Depot. But
no, if it's just to upload, there Git also has a UI that people can use.
Yeah. So let's start with this. There'll be one class where I'll be showing how do you write like a web service using Azure ML. So basically I think next class is where I want to start with R coding and R some packages, and we will do one case study in R, and then I want to show how we can use. I mean, I use Azure ML, but I think even Azure has something. Even AWS has something. But using Azure ML, I'll show you like how you can write the code, and you can write a web service to talk to that code, and you can get that back.
Cool.
Yeah. Okay. So I'll just do a quick recap of what we did last time. So basically, I think I have to repeat this once again. So basically, we did the matrices. The main thing in the matrix is the highlights of the matrix is basically we did all the matrix multiplication and stuff. Like this is useful, and if you want to learn matrices and stuff. But the main key point, which is important in matrix operations, is basically the determinant of the matrix. The reason for that being, whenever we are let me go back to whenever we are creating a matrix like this, right? So these are all the features, and then we are going to create a matrix of all the features because we want to actually predict these coefficients a1, a2, and an such that if we can linearly combine them to predict the label. So whenever we do that, the problem will be like this. So we have this times a matrix should be equal to the label. So, but then in general, if you're doing ax equals b, in linear algebra, the way you calculate A is you say B divided by X is this thing. In matrices, you cannot directly divide, so you will multiply it with the inverse of the matrix. So inverse of the matrix is, the formula is basically 1 divided by the determinant of the matrix times some operation. So if the determinant of the matrix is 0, that means you're dividing it by 0. So it will become like, so the inverse doesn't exist. So that is one key factor. And why is the determinant 0 is explained through matrix algebra. The matrix, so basically the determinant will become 0 when each of the vectors in this particular matrix is not linearly independent of each other. For that, we took a small example to understand what linear independence is. Like, for example, if you're actually getting the features from a house market, where did that go? Yeah. Let's say, for example, you're using the housing data and you're using features from a house market. The number of bedrooms, number of bathrooms, these two are two different features which provide you two different aspects of the information. But then if you're looking at the total square footage of the house and square footage of the bedroom, square footage of like the kitchen and stuff, this actually is dependent and can somehow be a linear combination of these two features. So therefore, that information is not relevant. So having the total square footage of the house and square footage of the bedroom, square footage of the kitchen, all these are interrelated. So there is no additional information which is provided by this new feature set. And that's why it is not, that's why we say it's not linearly independent of these features. Always we need to choose such features such that everything is independent of it's independent of the each feature is linearly independent, and that means each feature tells you something new about the data set. So for that is why we actually did the matrix algebra. Knowing the determinant of the matrix will help us. The other thing is the rank of the matrix. Let's say so if you actually use the numpy's rank np.linearalgebra.rank, it will tell you the rank of the matrix. The rank of the matrix tells you the number of dimensions which are linearly independent of each other. So let's say we have 10 features and you create this matrix, and you can, the two ways, I think someone asked, like inverse of a matrix is always for a square matrix. So either you construct, you take 10 observations randomly from that and construct a 10 by 10 matrix and take its in and then find its determinant, or you can generally take your whole matrix and take its transpose, and A transpose A is a square matrix, right? So that would again be a good candidate for finding the determinant of the matrix. But the rank of the matrix will tell you, like in this 10 features, if there is one feature which is a combination of the other ones, then the rank would be 9. If it is completely independent of each other, the rank of that is 10. So this is just a beginning step for you to understand, are your features linearly independent of each other or not? But you need not worry about, this was just to introduce to you the fact that, how we can do with simple math. But in the future, when I'll cover principal component analysis, that is one such math equation which will find what are the linearly independent features from your data set. So you need not bother about, like, if we don't do PCA, then you need to randomly take 9 features, 8 features, 7 features and try to find which are linearly independent. But if you generally do the PCA, then it will give you the linearly independent features automatically. So we'll wait till the PCA class to discuss that. But this is clear, right? This is like the fundamental thing in data science is how do you choose features. 80% of your problem is like how do you actually get features and what do you do with the data. 20% is like how you improve the feature sets with the data you have. So that is basically the matrices what we have done. But the other thing which we did last time is we looked at two packages. One is called a NumPy, and in NumPy basically we use NumPy for arrays and stuff. So what a matrix is nothing but a group of arrays, right? Because you can actually, every row is an array. So if a matrix 3 by 3 matrix is there, that means it's 3 different arrays. Each array is consisting of 3 elements. So if you create 3 arrays and put them in one grid, you'll get a matrix. So that's with NumPy. But the main thing in which data science generally uses is called pandas. The pandas package actually provides a lot of inherent in-memory data objects. Like for example, we discussed three main things which the pandas provides. One is series, the other is data frames, and the other one is panels. We won't discuss panels because panels is for 3D modeling and stuff. Series is simple one-dimensional thing. Like when you have like one data, like we've looked at like the stock market, right? Like if you take like one particular stock, let's say we take Amazon stock or something, it is just one particular data. Let me just open Matplotlib pandas. So we saw how we can create the series from an array. Like you can create the series from an array. But in general, when do you use series? When you have one-dimensional data, which doesn't have a second dimension. So when all the variables or all the numbers belong to just one category, we'll have like that as a series. So we generally use series for, like, here is the example. Like when you have like one-dimensional time series data, like the stock of a particular company and stuff like that. So you can create pandas series and then use the functions of pandas. But even series is also not something which we use that often. The main thing which we use is data frames. So data frame is basically in pandas is the way we actually read the whole data into one frame. So whenever you have two-dimensional data, by two-dimensional data I mean like you have rows and columns, you have different observations and stuff, you will read that into a data frame. For example, if you take we'll see video game sales tomorrow, later on. But if you take like the Indian liver patients, you have their age, you have their like different columns actually will give you different information, right? So all this is read into a data frame. And data frame also actually has the concept of accessing each column by the column name. So you can print out all the column names. So you can say, hey, if you don't have column names there, you can say the columns are this. But
Anna?
in case, yeah.
Sorry to interrupt. I have a quick question. Since you were talking about the liver patients, are you going to give us answers to the homeworks?
Yes, I'm going to send you the answers. In fact, we'll see some of them today.
Okay.
And then we are going to
like to see if our code produced the correct output or not.
Yeah. So basically, I have the solutions also in it. Okay. Data visualization analysis example code. Here is the exercises. All your questions which I asked you are I mean, I've already coded that here. So you have all. I'll send all this, even the solutions of this thing for both, and I'll give like even for video game sales data and stuff. I'll show you how to. I'll give you the solutions for it. But I generally want to like wait for some more time because some people they are still doing it. I don't want to like interrupt it and do that. But anyway, so the main function which we use for reading the data is basically pandas.read CSV. So in read CSV, you can actually give the path of it. Like I think Deepika had an issue with this thing, but that's mainly due to some corruption and stuff like that. But in general, read CSV will work. We'll see it won't work in the case of the video game sales data. I'll show you why. Because the encoding is different. So when we get to that, we will see this thing. But let's do some exercises on the Indian liver patients. So you guys already are either you created an assignment or you are actually working on the data, right? So first and foremost, like basically one thing is like, you know, how do you print out the column names of the data? So you actually say that data frame dot columns dot values will give you all the column names of that particular data. And so like, for example, I think this is the questions I asked you. Let's just go to the thing. And I think Deepika, you were asking how do I convert that into like a matrix and stuff. So there is a toList function which will convert things into a list and stuff like that. But the main thing is whenever you look at this data, right, like not And this is a very common problem in data science, is basically not all the fields have data. So in case like, because you're dealing with real-time systems and big data engines, so sometimes when you're querying the data from Cosmos or like, from PySpark and stuff like that, there is a fair chance that you will have missing data. Either you have missing data in your data frame, or you sometimes when you call the service and it doesn't give you the data, it's populated as nan. Nan means not a number. So number of null values in that particular thing. So let's do a quick exercise to see how many nan values are there in the data set. So the reason is, like, pandas gives you this additional. So first portion of our thing is data cleansing. So what we have discussed right now is we have 10 features. So using the 10 features, we can calculate. So did we do the rank of the matrix and stuff like that? Did you guys were you able to do that? Did you find out that if all the 10 features actually make sense?
Actually, I tried doing that, but I could not convert it into a matrix kind of a thing.
Okay.
Pandas have some rank function, but I think that's just to find out the highest of the column or something like
Okay.
that.
I'll show you how to find. Actually, I had written that thing. Let me find out where I did it. So I think I did it in variables. And go to the So I actually did. Anyone else who found out the rank of the thing to see if all the features were, if they're linearly independent and stuff?
No, I haven't. Can we do that?
Yeah, please go ahead and do that. I actually did it somewhere. I'm just trying to see.
Yeah, I was wondering if you could maybe go over it.
Sorry, give me 1 minute. Because I actually found the rank of that matrix and then. Oh, it's maybe in the matrices then. Oh, I'm sorry. Yeah, I think in this. Let me get this. So the one good thing about PyCharm is you need not say if you have a project and if you place it in that particular folder, it will directly take it. So you need not do add new things and stuff like that. So for example, I'm pasting my other thing called matrices here, and you will see that it will directly be populated here. So I can just click on this. So okay, I'll get back to that. I'll show you how you'll actually. I remember doing it somewhere. I don't remember where it is in this code, but I'll show you how you can actually find the rank of it. So what I did for that was I took the 10 features and I took 10 observations, and then I created and I did the rank of that matrix, and it comes out to be 10. So it means that all the features are generally useful for uh, for for the analysis. There are no features which are linearly dependent on each other. I think I sent all the code, right? Did any one of you see where if that thing was there? If not, yeah, I'll get back to that thing. I'm pretty sure I did it somewhere. I don't remember where. But anyways, so the first thing which we need to do before we apply any algorithms is called data cleansing. So data cleansing means that firstly we need to find out, we need to remove entries which are having null values, or we need to so first aspect is, when we have this data, when we read this data into a data frame, so you see that there is something in text here. So you can, when you try to use this as a feature, the algorithm will not know what text is. So the different things in basically doing data cleansing is, step number 1 is remove all nans or fill them with some value. Generally, we fill them with 0. Second thing is convert all text into numbers. What I mean by that is like it won't understand what male and female is, but we can generally make we can convert male into 0 and female into 1. So that way you'll convert the whole feature into a number. So instead of having the text, you'll actually have 0 and 1s here. So first thing, if you actually like for any project, first thing we need to do is clean this data, and by cleaning the data, we remove the NANs, and then the second thing is convert all the text into basically numbers. So let's quickly do a small like small thing on like first let's print out all the NaN values over there. So first step is analyzing the data. So analyzing of the data, like like I'll go through some of them. You need not try like do all of them here, but like how do you check? So I told you a function called dot head, right? The dot head will give you the first 10 records of that data set. So if you just say print, so I read the liver patient data into the data frame, and I use dot head, it will actually give me the first 10 entries of that particular value. And then shape, like it'll tell you like how many rows are there, how many, like shape generally returns rows and columns. So shape of 0 will return you rows, shape of 1 will return you the columns. So number of columns will see, shape of 1 will tell you the number of columns. So this is the initial thing of like understanding what are there, like the column names in the data, what is the type of each column. So actually do this, read the CSV file and then print out the type of each column. So this is really important because the D type will tell you what D type stands for data type. The D type will tell you what kind of data type it is. So are all of them floats, are all of them ints, or are there any strings in it? So read the data set into a pandas data frame firstly, and then print out all the column names. How do you print out the column names? Dot columns dot values will print out the column names. And then when you do dot D type, print out that and tell me if, obviously there should be one row which is basically having gender as male and female, right? So quickly print out the names of or the D types of all the column names, and we'll see which ones should we process. Let me know once you have done with that. So print out the data types of each column. So the way we do it is just by doing dot D types. So is it done? So then if you're done with that, find out if there are any null values in that particular data frame. The way we actually null or nan values is basically, I told you, right, there are two functions in the data frame. One is called isNull and the other one is fillNA. So fillNA we use when you want to refill those null values with something else. So whenever you don't have any data there, it will actually replace that with, like, if you want to fill it with zeros or something. But in general, what we do is we avoid those entries, because when you feed that to the algorithm, because calculating inverse operations and stuff, if it finds that there is not a number, you cannot multiply not a number with any number. So we first go and delete all those not a number values from the thing. But before we do that, we need to know if we need to do it, right? So the way we actually find that thing is, again, you take the liver patients and say if it is null. If it is null, then you actually so dot any. So these are all. So there are a lot of functions in data frame. So we cannot cover everything, but then we will learn the functions as and when we need it. Like, because if the problem is to find all the nan values in the data set, then we will go and see what are the functions which will help us, because there are like umpteen number of like assistive functions for each data set, and we cannot like learn everything. But what we will do is, like, for example, if the problem is check to see if there are any nan values in the data set, then we actually go and then find out to see, like, in the liver patients, is there anything null. Dot any will actually convert all those things into indices, and then you will then make a to list. Like, let me run this thing so you will probably see. So here, so did you guys get this thing, the data type of each column? You should get it like this. Age is an integer, gender is an object, which is basically doesn't know what it is. Rest all of them are either float values or int values. Did everyone get this when you printed out the D types?
Yeah, we got it.
Yeah, so now we know that this is the one which we need to change, because this is an object type, because it's gender, right? So that is one information which we have. The second thing what we will do is, so I asked for number of male patients, female patients. So this is the question: which of the following columns have null type? So it says that albumin and globulin ratio has null type, and the number of values which are null in this is 4. So again, the way we do that is basically first is null. So take the whole data frame and then find is null dot any. It will tell you which column will actually, the index of the column which will which has these null values, and then I converted that into a list. So that will give you all the columns which actually have the value null, and then I'm just printing the string version of that particular column. So you will see that in this particular column name, albumin and globulin ratio, there is a null value.
And now, why did you have to convert columns with null value into a string? Is it as an integer right now?
Because no, it's basically just to. I mean, ideally you need not, because it is a string name. But but you could actually, let's say if the column names are 0, 1, 2, and 3, right?
Yeah.
Like if it had like 0, 1, I just like
Okay.
this is more generic code. Like in this particular case, you need not. But if you want to typecast it into a string, then it will convert those values into into an integer, into a string.
Sai, what is a sprint separator?
Oh, that is basically just asterisks.
Okay.
So I mean, just to, because the whole program is written here, right? So I just made a separator is asterisk, so that each one is different.
Okay.
So separator is nothing. I just created separator up here. See, separator is a string which prints.
Okay.
So that I'll know the differentiation between each of the.
I thought it was more connected to this problem that.
No.
Because they're just repeating for.
No. Separator is just asterisk, so that it is basically this thing. So that now we know column has null values, we generally go to each column and then in these null values and print out the number of null values. So what I did is I just took is null and then did a sum of that. So when I do sum of that, it'll tell you like how many null values are there. So this is the first step, how you analyze the data. So we can't generally like look at like initially when you look at it, it's very difficult to spot also, right? Which one has null values and stuff, because it's like so much, like this is just 500, but if you look at video game sales, we have 15,000 points, 15,000 entries. We cannot like sit and like look at this. So first thing, these are like handy functions for us to tell you where the null values are and what is the sum of those null values and stuff. So first step is we finish analyzing the data and then we clean the data. So step number 1, analyze. And in analysis, you need to understand which columns have objects, which of them are not integers, and which columns are actually having null values, and then which columns are having missing data. So there's one more thing called missing data. So if there's missing data, mind you, there's a difference between missing data and null. So when you don't have any entry, like if it's blank, it's missing. But when you actually like if your result of that particular CSV is some wrong division or something happened, right? So it has to put in some value there. It'll put it as not a null, not a number value. So that's the difference between both of them. So first, once you analyze the data, second step is cleaning the data. So in cleaning the data, what we do is basically first thing, if there are any categorical variables. So what is a categorical variable? Categorical variable is something which is not a numerator. Which is something which is not a number. Its categorical variables are gender, like for example, male and female. There are 2 categories, right? So if there are any categorical variables, they have to be converted into numbers for classification. So for that, so this is how we actually, so let's do this program. So we are actually, let's write this thing, because if you write this particular program, I'll give you the video game sales for homework. So then we'll do, let's actually code it along with me. So you're reading. So is that clear? Like firstly, we found out which columns have these null values and we printed them out. And then we did D types to know which one of them are categorical values. That's clear, right? So now let us write this code. So create another Python file called cleaning IndianLiverPatients.py. Read the file. So in this file, what we'll do is we'll output the clean data. So we'll output it saying that this is, I mean, wherever your data set is, no need to follow where my path is, but we'll output the clean data saying IndianLiverPatients.cleansed. And then for all our visualization algorithms and for all our future algorithms, we'll use the cleansed.csv. I mean, if you want to like see the difference, you can use the same the raw data which we read, but your algorithms will fail because either they'll encounter not a number or they'll encounter a gender object, so they won't know how to interpret it, so it'll give you failures. So this is the first step in data processing, is you read the data frame. So please code, you need not code all of them, but the main things we need to code. First thing is remove the categorical variables. So the way we actually do that is basically we first read the CSV and see that again, like as I said, right, data frames have so many functions. So we will just do the functions on a need to basis. So what is our need here? First, find the column which has object data types, and then replacing them into with a number. So if there are categorical variables, so there is a function called dot select d type and exclude anything which is a number. So what will it only include? It will only include the ones which are objects. So as we have seen in the previous output, so when we did this analysis for d type, all these are numbers, int, float, int, but only one of them is an object, right? So we first say we want to select the d types, but exclude anything which is np.number. So that will basically give you that particular data frame, which is basically having the gender objects. And then we will say print out that column name. So this is again a data frame, a sub data frame which is got from this data frame. the column values for that, it'll only have gender. And then what we'll do is we'll take that column and then we'll concatenate it with codes. So, okay, let's do one step at a time. Did everyone get this? Like, print out what DF, which column it is. So select that particular data frame which is objects and print out which one has print out the column name which has the not a number thing. So you should technically see the output like this. So the column name which I printed out, which is not having numerical data, is the gender name. And then so
Wait.
yeah. So did everyone get the gender name as the column name which has categorical values?
It says it doesn't know what np.number is.
You have to include numpy. So NP is basically coming. So you use pandas, you use numpy, right?
Yeah.
NP is number. So if you don't include numpy, then it won't understand what np.number is. So the thing is, the more you write functions on this data frames, the more you'll get accustomed to like loading the data really well, analyzing the data, and then converting the data. So today we'll do this, then I'll go into plotting. There are like beautiful plots which Python can plot for you. So we will use the same example of the Indian liver patients to understand like how plotting is done and what are the different kinds of plot and which one of them is useful for our problem today. But everyone, like the first step to any problem is cleansing the data. By cleansing the data, there are two standard rules. One, anything which is non-numeric has to be replaced. And second, anything which is which has these nan values or missing values should be deleted from your data. Did everyone get the column name?
Yeah.
What about others? Raghav, Deepika?
Again, I'm just still working.
Yeah.
Okay. Is Satya there?
Yeah, I got it.
Okay.
Yeah.
So how do we actually now assign codes to this particular thing? So again, pandas has this another function called dot categorical. So what that does is it takes your anyway. So if you have gotten that, what I've done here is I've taken the column name because I know there is only one value, right? Because I printed out and I saw only gender is the only one value. So mind you, what is this doing? When I say select D type exclude number, it is creating another data frame with your option. So DF number is another data frame which only contains the gender as the name there. So it'll print out the, like when I did this, and here that's why since I know it's only one value, I'm saying values of 0. Ideally, if there are 2, 3 of them, you shouldn't hard code it to 0, but I took the leverage because I know that there's only one data frame. So the question here is, if you look at, let me see how many of you followed this thing. If you look at the data frame here, which column is gender? Which column is gender? So this is our original data frame, right? So what column is it? Is it like what number of the column is it?
1, right? 0,
Yeah.
1.
So 0 is age and then gender is 1. So if you look at here, I'm saying values of 0. Why would this work?
It's in a different data frame.
Exactly. So here the select D types is actually creating another data frame which has the columns which are not numeric. In this case, the data frame here will only contain the values of gender. So that's why this data frame has only one value. That's why I'm saying values. So, and everyone understood why values of 0. It's a different data frame. This data frame is an output of the select D type values. And then I'm using that particular data frame and get this column name. So there is this really cool function in pandas called categorical. So what that does is, if you pass it the column name of whichever value is not an object, it will create a dot categorical will convert that into zeros and ones. So males is 0 and females will become 1. So all I'm doing is I'm converting. So I got the column name here, right? The column name is gender. So I'm just referring to that column name and passing it to pd.categorical and then reassigning back to the same column name. So now what this does is it converts all the genders into zeros and ones. And if you want to see what kind of a code it has, then you can actually say dot category dot codes. So generally 0 and 1 is the category codes. If you have, let's say if you had like, maybe not gender, but if you had like 3 valued categories, right? Like let's say color is there. So blue, green, red, and this thing. So then if you want to see which category is assigned to what this thing, you will say dot cat dot codes. So that will give you like which one is assigned to what. So this particular step is really important to convert. So that finishes. So where is my notepad here? So first step is, okay, I think I did the reverse order. We did the second one first. Convert all text to number. So dot categorical will convert everything to number. We are still not done. What are we still left with? We are still left with removing all the column, removing all the entries for which we have null values, right? So just for your satisfaction, right? Like after you actually convert it into categorical and assign that particular column name to your data frame, print it out and see. It should no longer have male and female.
I am just getting some execution error. My Python's quitting whenever I'm trying to execute this.
As in PyCharm is quitting, or
Python's stopping, so probably it's unexpectedly. It says it's unexpectedly stopping, and
do you want to share your screen?
yeah.
I'll stop sharing now.
Okay.
Okay. So Indian liver patients is in the same project, right?
Yeah.
Same folder. Okay.
It's in this read CSV. I'm actually doing abc.py because I was trying to clean up things.
So that is fine, but the thing
it's in the same thing.
No,
You
it says there is no module called pandas. So what you have to do is go to project. Yeah. Oh, you don't have set out interpreter. Go to read CSV.
It has pandas.
Oh, okay. Why is it saying click OK? Connected to console courses. Import pandas as PD.
Shall I just go ahead and create another project?
No, but that shouldn't be the case. Every single time you shouldn't be running into this issue.
Yeah.
Right click and so when you say right click and run, system can't initialize this standards. So something with your OS.
Yeah. Not sure. It says Python quit unexpectedly.
Yeah, it's I'm not a Mac this thing, but I think it's something with your OS because
yeah. Shall I just restart my system? Usually
no need to restart. Then you'll lose this thing, right? So it's okay. Like I'll send these things anyways.
Okay.
So try to run it afterwards also if this is, because this is not something usually I see. But just follow the class along with me right now,
Okay, yeah.
and then I'll send all the code, and then you can run it and see.
Okay.
But the main thing is like, how do we actually? Yes, you can stop sharing your screen.
Even I got stuck similarly, like from the reading the file perspective.
Can you share your screen also? Is it the same error? Are you using Windows or are you guys using
Windows.
Okay, I can help you better if it's Windows. No, but no, the class doesn't have any Windows requirement. It should work on Mac also, but I think it's some kind of an OS problem or something. Okay. So you are printing the whole this thing out, okay?
Yeah. So this is error.
You're printing out the whole data frame, right?
Yeah.
No columns to parse from the file.
So the CSV file is in the same path.
Yeah, can you open that file? It says no columns to parse. I'm just curious. No, this
So
is
there's no data.
no. This is book one. It's not your. It's not that Excel. So it's something else. Looks like you already have. Okay. So this is your Indian liver patients. You should be having all the data. This is the same one, right? Same one from where you're opening.
Yeah.
Okay.
Let me.
Yeah, save it. I don't think it will. Is this where your Python is running?
No, it's not.
So I think it's a different folder. I think it's not fourth grade. You actually, maybe it's the Python there. No, go down. Down. There's personal and then there's Python. Maybe it's there.
No,
I actually created another project and it started working.
Yeah, I think something is corrupting your environments. I don't know why that is happening. So it's not on network. So I just wanted to check, like, if the CSV file which you're reading is the one where you actually have this particular project.
I think it will be users.
Okay, just save.
Yeah, this is where it is.
Yeah, so this is where you just save it and I say override it. Yes. Now try it once again.
Now, do I need to close this file?
Close this file. I mean, you need not close. I mean, as long as read operation is there, if you're writing, it will give her this thing, but this should actually work unless there is something. Yeah. I think the one which maybe that one, the file wasn't correct or is not right or something.
Okay.
Anyway, so now it's working.
Yeah, I'll progress.
Yeah, you can stop sharing. Oh, there's some questions on the chat also. Okay, let me again share my desktop. So the first thing which we are doing here is, as I said, we've removed the categorical values, and then we are getting the column names. Once we print out the columns, it will be 0 and 1s. You can check which column names you want by saying .cat.codes, but I mean that you can do it for assignment. Second problem is to check if there are nan values and remove it. So the way we do it is similar to what I've told before, right? So you take the columns and then you first take the data frame. So the way you build this is, first thing is, how do you find which columns have it? So you take the data frame and do is null dot any. So that will give you basically all the indices of the columns which actually have the null values. So, and then what you do is, if there are no columns, if the column value is not 0, then which of the columns have null values, you can see in this will be populated with that. So once we have that, what we do is, then we print out which of the columns have it. You need not do all that, but then for each of those columns, I've replaced either, I think I've done it with each. So get the zeros, the count of zeros in that particular column that has null. Get the count of zeros in the column that has null. Okay. Set the null. Okay. What I've done here is I've replaced the value of that particular thing to 0. So remember I said there is a function called .fillNA. So it will take all the null values and you put 0 to it, and then you say replace in place equals to true. That means wherever you're finding the null values, you fill that with 0 values. So the reason I found the 0 values before is because I'm adding these zeros artificially, right? So initially, if by mistake there were already zeros in the thing, so that's why I found out all the columns which actually had the count of 0, and I printed that out. And now I'm changing all the NA values to 0, and now I'm printing the new column. So now this difference should be equal to the number of null values which we had. Is this clear, or I think did everyone follow this? I can explain it again. So all I'm doing here is I'm saying I want to, so the column whichever has the null values, I'm just taking dot fill NA. So what that fill NA does is it replaces the null values with 0, and mind you, you have to give dot in place, because if you don't give in place, it will create another column and return that value. But if you do in place, it will take this column only and replace the values of that particular column. And then after that, I just now I found out what the new set of values which are set to 0. So initially, let's say there were 10 zeros and there are 4 NA values. So now after replacing it, we should have 14 of them. So that is the basic check which I did. And then once we actually create this new data frame, then we output it. The way we output it, say Indian liver patients. So we did read from CSV, right? To CSV, we give the output name, and then it will save it. So this is a very important step. Which
what is the index equals false in that output?
So basically, you need not give that. Actually, it basically means like you don't need to follow with that particular index. So I think this is just, again, like I just wrote these programs which are like good programming practices.
Okay.
But you need not worry about that. But you understood what in place is true, right?
Yeah.
Okay.
So Sai, this is going to create a new CSV, right?
Yes. So I'll open that new CSV. So if we run this thing, so if you run cleaning this, so it will create a new CSV called cleanse data. So where is it? I'm doing session 3. Sample code, cleaning data cleaning, Indian liver patients. So I'm actually writing it to the same. So I actually made a folder organization like this. It's up to you. You need not worry about like created this thing. So let's look at this thing. So now you can see that those null values will go away. And you see the gender now became zeros and ones. So females became 0, male became 1. And then we can actually search control F. Let's search for 0. Find out. It found out all points also. But if you actually see, there'll be exactly, we found like 4 null values, right? All of them will be replaced with 0. So now we are done with the data cleansing aspect. So,
So if you don't mind, can you quickly share only this part of the, the code from reading the file to this part?
From, sorry, it just how to replace null values, nan values, or?
No, probably the entire code actually, right from the reading the CSV to this. I'll run it.
So we'll just walk. I'll share this particular file with you like after the class. But just to quickly recap, what I did is I read all the CSV file into the data frame. Then I found out. Then I actually just printed out all the column names. Then I found the values. So select.dtype where it's not a number. I selected those into another data frame, and then I used. So this is one data frame, but it only has one value, right? Because it's only gender which doesn't have it. So I just got the column name of that particular data frame. So that is dot values of 0. The reason it's 0 is because it only has one column, which is gender. So once I have that column name, I use pd.categorical with that particular column name, saved it back to the same column name. So what this does is it takes your old data frame, whichever one has the gender, it will replace everything with categorical values 0 and 1 and create the new data frame here. So that does the first part where we have removed the male and female names. Then for the second part, I did the same thing because in the analysis, I did this code, right? Where I said, are there any null values? Find all the column names which have null values. So Indian liver patient is a data frame. IsNull.ne will return you all the indices of the column names which actually have null. So I found that if it is not equal to 0, then we have some column names which have null values. Then what I did is I found out all the values because I'm using fill NA, right? So what I did is first, before I did fill NA, I found out what columns are actually equal to the value 0. So I got that count. And then after that, what I did is I replaced all those NA values with 0. And then again, I did the same thing to get the count again. So now the count of the number of zeros should increase by the null value. So let's say initially we had 10 values which were 0, 4 values which were null. So once I did this fill NA with zeros, then again when I try to find zeros, it should be 14 because I converted the 4 null values into zeros. So I'll send this code to you because we don't want I think if everyone got the gist, we'll go into plotting because it might take some time to write this, right? So is that clear, Raghav? What we've done?
Yeah.
So
yeah, I mean, just to be with speed, right? I just wanted to run in my environment.
Okay, so
I can do the rest along with you.
Let me do this. So I'll just send the whole code. You can just copy paste it from this thing. The whole code is there in the chat. So you can, if you just want to run it, you can just copy the code from there and run it, but I'll send it there. So at this point, so everyone understood what data cleansing is, right? Why do we need data cleansing and stuff like that? Because if you encounter any of these values which are categorical or with this thing, then we won't be in a stage where the algorithms can process this data. Algorithms only know numerical values. They can't process string values. So having said that, let us actually explore the new another Python package called matplotlib. So matplotlib is the package in which we can do a lot of visualization. So the next half of the lecture today will be on data visualization and different kinds of plotting graphs and charts which we have in Python, which will help us visualize the data. Before I go into data visualization, why is data visualization important? Like, why can't I directly I know the problem. The problem is for me to find and train an algorithm where it differentiates between people with liver disease and without liver disease, right? The whole data set actually revolves around the fact that there are two data sets here. One patients with the liver disease and other patients without liver disease. So we need to find an algorithm which can differentiate between both of them. Then why am I spending so much time on cleaning the data? Well, cleaning is understandable because the algorithm, when you train it, if it encounters not a number, then it'll fail because it can't process. But why do you think I need to visualize the data? Any ideas as to why data should be visualized, or why even make an effort to look at the data? You can take a guess also. I mean, it may not be the exact answer.
Can you repeat the question again?
The question is, why do we need to visualize the data? Like, we have the data in the Excel format, right? Why should I actually plot this data into a nice plot and then see the data and stuff?
So that we can find trends.
Exactly. So one is trends, and the other thing is whether the data. Maybe this is a good time to tell you. I've been telling we need to train a machine to learn or differentiate between the algorithm, or differentiate between the data and stuff, right? What does it mean when I say the machine needs to learn? What is meant? Let's answer the fundamental question as to what from this data, like you and me, we learn. When we say you learn or I learn, it's basically our brain understands it. The machine is just a dumb thing, right? It doesn't have a brain. So we can't say the machine understood it. So for that, I'll just take one liberty to actually go ahead and show you a scatter plot. And then I'm going to show you what exactly is the machine learning here. So for example, in this case, so we'll plot this right now, but I'm just taking a step ahead and then plotting this graph for you. I just want to show you what is meant by learning. When we say machine learns this data, what does it mean? So here is one plot. It's called a scatter plot. I'll show you how we'll plot it and everything. You will plot it as homework and if possible in today's class. So this particular plot is between male patients with disease and male patients without disease, but it is the plot between two features. One is the alkaline phosphate. You can see from here there is alkaline phosphate, this one, this particular column, and the other one is bilirubin count, so which is this column. So I've taken this column and this column. So I've taken these two columns and I plotted this for patients with the disease and without the disease. So as you can see here, the visualization gives you a better understanding of how this data is. Male patients with disease, you can see that their bilirubin count is really high and their alkaline phosphate count is also really high because these points are way here. So male patients without the disease, if you see, they're all clustered here. So what does that tell you? It tells you that for patients with less bilirubin count and less alkaline phosphate count, it is very unlikely that they'll get the liver disease. But you and me understood that. But how will the machine understand this? Like when I'm training the machine, when I give this is the data I'm feeding to the machine, right? So what will the machine do with this data which will make it intelligent to make a decision? Any guesses on what should the machine do? Let's say if I give you this data, mentally you are able to visualize and understand it. But what does the machine do?
Didn't you say like it creates a box
Exactly.
within
So
the?
our algorithm basically is nothing but it has to create a decision boundary. So this is so from now on, whatever algorithm we learn, whether it be supervised learning, unsupervised learning, the thing which we teach the machine is to how to draw this decision box or a boundary. Like, let me show you this in the dashboard. So when we say a machine learns this, what I mean by that is the machine learns the equation of a decision boundary. So now in this data, we have like people without disease are here, people with disease are here. I'm just like interpolating the data. So these are all people with disease, and people without disease are clustered here. So in a when we say we are teaching the machine, all we are doing is the machine needs to learn this boundary. Machine needs to know equation of this line and equation of this line. So then we tell the machine that anything which falls beyond this mount. So this is our training, right? In the training will help us get these two lines. So once the training is done, so now it's done. So using this training data, we arrive at these two lines. So once it is done, all this data is gone. So what the machine knows is only this. It will learn this line and this line. And it will know that anything which is in this area is supposed to be, people will not have the disease. Anything outside the area, people will have the disease. So when I say we are teaching the machine, or when the machine is learning, machine is really dumb. All it learns is equation of this line and this line, and then which area does the data need to be so that it doesn't have the disease. So once it is done, the machine will not, all this data is useless because machine already learned it, right? So all this data is gone now because this data is helpful in determining these boundaries. But once the data training is done, the machine actually learns these two lines. So now when you get a new data point, so now this is a testing phase. Now you get a new data point. If the data point lies here, you ask, hey machine, does this person have a disease or not? What does the machine do? It'll know that, oh, I know this equation, I know this equation. Let me see which side of the line does this fall. Oh, it'll see, oh, this is on this side of the line and this is on this side of the line. So this person does not have disease, no disease. And let's say if the data point lies here, it'll say, oh, sorry, I'm sorry, this is, yes, this is disease, right? This is disease. And if the data point lies here, it will say no disease. So all we are doing, all this effort which we are doing to train the machine is for it to find this decision boundary. So this is a simple case where we actually have a linear decision boundary. But let's say if the data is not like this, like, because this is a simple example which I showed where the data can be linearly separable. What if the data is like all over the place? Like this is here, this is here, this is here, this is here. So not all boundaries are linear. Sometimes we'll have to come up with a complex boundary like this and say anything in this is having disease, anything outside this is not having disease. So again, in this case, the machine learns this boundary. This is the decision boundary. So the process of teaching a machine or the machine learning process or different algorithms are only helpful in creating this decision boundary. Once the machine knows this decision boundary, it will check on which side of the boundary is the data for testing. So when you get a test data, it will check, oh, if it's on the other side of the boundary, then it is basically saying, hey, this has the disease. If it is in this side of the boundary, it will say not have a disease. Is this thing clear? So this is the fundamentals of machine learning. Like what exactly are we teaching the machine is basically how to come up with this decision boundary. Human brain actually comes up with this decision boundary somehow. Like, we don't need to like think of equations. Somehow humans understand this, but internally in human brain also, we draw a decision boundary. When we look at a person in different attires, right? Like when we like it's similar to a machine. Like when we look at okay, when we see a kid wearing a school uniform, somehow our brain tells us that he came from school or he's going to school. When we see him in normal uniform, we'll think that, oh, he's at home. Because even our brain takes the features of the dress and it somehow drew a decision boundary somewhere. It will see that, oh, if it is not wearing the school uniform, then he's at home. And if he is wearing the school uniform, then he's at school. So even our brain constructs this decision boundaries, but human brain is really complex. It can come up with variety of decision boundaries. But machine is really stupid. You need to teach the machine. So in this case, it's pretty straightforward that these two lines are the decision boundary. But when we learn like more complex algorithms like support vector machines and decision trees or boosting and stuff, we'll see that this decision boundary can get very complex. But all we are doing in teaching the machine is by saying that this is the decision boundary you need to follow in training. Once the training is done, then it will only remember this decision boundary and see wherever the new data is coming, it will see where it falls, and then it says whether that person has disease, doesn't have a disease, or he's going to school or is not going to school. Is this thing clear? The whole machine learning or the algorithms and everything which we are learning is basically fundamentally this. How do we teach the machine the decision boundary? It can be a simple equation where you teach it 2 lines, or it can be a complex equation where it is like this. It's like complicated boundary. Did everyone follow this?
Anna, by doing this, we're assuming that everything has a secret pattern to it that we can characterize with an equation.
That is correct. But if the data is so complex that it doesn't have a pattern, then machine learning will fail. You cannot apply machine learning to this thing. But you will be surprised that machine learning algorithms are so complex. Right now, we are only looking at 2-dimensional plane. So when I teach you PCA and stuff, their eigenvalues and eigenvectors, the machine will project this into a different space. It will increase the number of dimensions and stuff and try to come. So technically, you're right, but then the math is so advanced that it will, from given any pattern, it will create another space where these both can be separable. So that is the next step of algorithms. So in most cases, unless and until there is nothing which can, like a simple example is, I'll tell you, like, teach the machine to separate apples from oranges. But let's say if I only give you oranges data to train, there is no way the machine can tell, right, whether what it is. So it's just, so in such cases, yes, if there is no patterns, then the machine learning can't learn. But in most cases, the machine or the algorithms are so smart, when we'll go into support vector machines, you'll see that even if the data is like really mixed up, it'll somehow find a decision boundary. So that when we discuss support vector machines, I'll talk about that. But is this thing clear at this stage? Like, all we are teaching the machine is basically the decision boundary. Is that clear? Any questions at this point?
It's clear.
So basically, why did I tell you this? I thought I'll tell you this when I thought I'll introduce machine learning algorithms. The reason I told you that is, now you'll understand visualization much better. So now you see the data like this. Now you can say, like, I think Meher was asking the question. Meher, in this data, do you see that there is a pattern which the machine can follow to make a decision boundary, right?
Yeah.
So now it will tell you that, now that, okay, if the data is like this, then I can use a machine learning algorithm to classify it. But if the data was all over the place, like even these dots are here, this thing is here, then you would know that there is no simple algorithm for it. Then you will go into like more complicated algorithms like decision trees or support vector machines, or even deep learning models and stuff. But right now it will tell you that since the data is behaving like this, we have a way to actually create a machine learning algorithm to separate this. So that is one fundamental thing with data visualization, is to understand which kind of algorithm should we use. Like, if the data can be easily separated, if you see that there's an easy decision boundary here, you'll use more simpler algorithms. The more complex, so always remember the rule. Don't ever go and say, don't ever go for the most complicated algorithm. because more complicated algorithm will need more computational power. It might run into like some other trade-offs. If it is a simple problem and there's a simple solution, always go for the simple solution. Don't complicate models. In this case, when you look at this data, it is very evident that you can use a simple linear separation to actually separate this data. So that is one reason why data visualization is important, is to understand how the different aspects are. Like this is one thing, right? The other thing, this is the female data. Even in this case, you see that there is a cluster here, and anything like which is varied above, like has total higher bilirubin count, even for male and female, it is going to be the same. And then there are other plots, like for example, oh, this is only the scatter plots, okay. But is this thing clear? Like, why do we need to visualize the data? The data visualization will serve as one, to know if a simple machine learning algorithm can be used. If not, then we can go for complex machine learning algorithms, and it will give you an overall idea as to how the data behaves. Clear? So now we'll go and see what are the different kinds of plots which we can actually use to analyze this data. Any questions? So I'm assuming there are no questions. Did everyone understand what decision boundary is? What are we teaching the machine?
Yeah. Yeah.
I'm hearing some kind of a noise. I don't know from whom. Okay, thanks. So let's go ahead and, so again, data visualization also actually helps in a lot of things. Like for example, right, I gave you one image of usage of programming language, and I give you one statistical data. So clearly, when you actually see these images, like the histogram plot, you can actually answer the data more, right? Like human brain is generally used, I mean, it's more used to interpreting images because that's what we see every day. So you don't see data, you don't see like numbers. Numbers is something machine understands. But even, and one other use of like data visualization is if you're making presentations, right? Like generally, you know, management and everyone, they prefer nice pie charts and like these graphs. So, but as engineers, I think we can look at the data, but it's generally helpful for like people who are not like you know, who understand visuals better. It is generally useful for helping them, and also it gives us an idea of how the data distribution is. So let's actually look at Indian liver patients. So this is another plot. So there are different kinds of plots we'll learn today. So there are two plotting algorithms. I actually asked you to download Matplotlib and Seaborn, right? Both Matplotlib and Seaborn actually provide you a lot of plots and charting algorithms which you can use to analyze the data. So one of the plots is the kernel density plot. So in kernel density plot, it actually tries to, like, it shows you how the distribution of the data is. And you can clearly see that people with the disease are actually having a higher distribution of whatever this feature is. I don't recollect what the feature I drew here, but people without the disease have a lower distribution of that. I think this is bilirubin and alkaline phosphate. So you can see that kernel density plot will also tell you like different. Let's start with basic this thing. So again, as I said, like there are bar plots, which is just this thing. There are scatter plots. This is scatter plot is something which I showed you. What it does is it takes all the data and scatters it all over the graph. So scatter plots, so generally scatter plot is the most useful whenever you want to like analyze different kinds of data. So we generally use scatter plots as the first means. Then there are box plots and Weiland plots. I think I covered box plot a little bit in the last class. I'll tell you what a box plot is, right? So I mean, as a recap, so whenever you have the data, the center of the box plot represents the median. The lower end represents the 25% quartile, and the upper end represents the third quartile. So first quartile and second quartile. So I think we discussed what quartiles are last class and how we find the median. And then but these are called whiskers. Whiskers are the extreme ends of the thing. So how are these whiskers calculated is basically you take this particular plot and you calculate something called as the interquartile range. Interquartile range is simply nothing but the difference between the third quartile and the first quartile. So everything in this green is the interquartile range. So again, let me repeat myself. So the middle line is the median. The upper the upper line is the third quartile. The lower line is the first quartile. And interquartile range is the difference between the third quartile and the first quartile. And these whisker plots are nothing but 1.5 times of the interquartile range. So you basically draw these two things. The reason we draw this is because it will tell you like these are the extremes beyond which anything else is an outlier. So for example, if you see this particular thing, right, there are different samples. Like for example, let's say if this data belongs to let's say tablets, right? In the pharmaceutical industry, we are taking tablets like let's say paracetamol is one, but paracetamol manufactured by one company, paracetamol manufactured by another company. There are 4 different batches. So and we are taking the weights of the paracetamol tablets. So you will see that in the first batch, basically most of it is concentrated here. It's at 100, and there are few outliers. Outliers are the ones which fall beyond these whisker plots. And then in this one, you see that there are some samples which are way beyond the extremities, right? So it'll be easy to identify in the data what are the extremes and what are within the mean. So that is what a box plot is. So box plot is generally useful for understanding data to see, to just get an understanding of the distribution of the data. So like one example, before I go into that example, let's just, so there's another plot called Violin plot. Violin plot is the same as box plot, but instead of having the mean, it'll show it as a curve. So the mean of the curve, median will be here, and then it'll show you how the data tapers down. So if you look at, like whenever you look at like normal distributions and stuff, right? So you look at the data, you'll see that the mean is generally the highest because most of the population is around the mean. And then it slowly tapers down where the extremes are basically, the extremes are the outliers. So if you look at, if you superimpose the Violin plot onto box plot, it's nothing but, I think if I turn it upside down, right? Like, let me do this. Is it not turning? Yeah. So this is what a Violin plot looks like. So if I actually compare box plot and Violin plot side by side, so the median is where this thing is, and the rest will be basically tapered according to like how these extreme things are. And it's nothing but so left and right are just mirror images of each other. So when you look at this, you will see it will give you a better understanding of the data depending on, here I just say the median lies here and I say it is 80, but this will tell you how many samples are there at that median, right? So if you look at this, it'll tell you that the median is here, but also it'll tell you how many samples are there. Like there are 20 samples which have that particular value. The other value has like 20, like lesser number of values and stuff. So that's why box plots and Violin plots are more interesting because it'll tell you how the nature of the data is distributed. Do you have any questions on the box plots or Violin plots? Do you understand like what does it signify? Any questions on these two?
Yes, right. Like other questions. The way I understood is it's the application of this is in terms of finding out the statistics of the data set, right? Like
Exactly.
Where the median and then how each data set is variant from the median.
Yes. So it's to understand the statistics of the distribution of the data set. Like whenever you get like different data set values, when you get like different like for example, I gave you one example, right? Pharmaceutical industry. Let's say you get samples of paracetamol from 4 different companies. So you want to see how the weight of each tablet varies. You'll generally plot this. It will give you an understanding as to where the most of the mean is concentrated, where most of the outliers lie. So at this
like the bell curve, right? Is it similar to bell curve? Yeah.
Bell curve is basically, that's the kernel density plot. So this is a bell curve. So it'll tell you like where the kernel density is. It's very similar to bell curve. If you actually see if you just see the top portion, it's just like a bell curve, where there are it has more values on this side, but the mean, median, and everything are here. So it'll tell you like how much population has this and how much population is towards the extreme. So let us, so if you understood what box plots and Violin plots are, so let us see how do we plot them. So box plots and Violin plots are functions of this library called Seaborn. I want to do these two because these two are more important. The bar plots and all this, like it doesn't tell you much, but this is really important in data analysis where box plot and Violin plots tell you. So let's quickly do this. And now is the time where you take the data from the snowfall text file. So let me show you. So everyone installed Seaborn, right? Seaborn, and so there are 2 things I asked you to install: Matplotlib and Seaborn. Let us go to Seaborn. So the way we actually use this is basically, so it's very simple. So you actually import Seaborn as whatever name you want to give, SNS or something, and then you say SNS box plot, and you just give the data points. So whatever your data is, and then you give this. But I think what you need to do is, maybe I skipped this step. How do I do this? For now, so these 2 are functions of Matplotlib. I'll cover Matplotlib in like next 10 minutes. But for now, just ignore or just blindly copy these lines. I'll tell you what this means. So what this does is it creates the box plot, but then you need to have a plotting chart to put it. So plt.title will give you that chart, and plt.show will tell you what it is. I'll talk about this in the next 5 minutes, but everyone quickly create a box plot. Take some random array points. So create an array. So firstly, import Seaborn as SNS and import the plot library of Matplotlib. So Matplotlib has a sub package called pyplot. So import Matplotlib pyplot as plt. These 2 lines just blindly copy for now. I'll tell you what that does in a bit. In the next 5 minutes, I'll tell you what that does. Create.
Wait, and all these plots that you showed us are part of just Matplotlib?
No, the plots. So some of them are part of Matplotlib. The more complex plots like Violin plot, plot, Whisker plot, they're all part of Seaborn.
Okay.
So Seaborn is like an extended library. So Matplotlib has most of the standard ones like histogram. It has like the other ones like pie charts, and all that is part of Matplotlib. Okay. But the more data intensive ones are part of Seaborn. So right for now, just copy the Seaborn this thing. So scatter plots are also part of Matplotlib, but Seaborn has these like other data analysis stuff, which is like box plots and Violin plots. So just copy these 4 lines for now. For create an array with like some values, and then just run this. Everyone should be able to. Everyone should be able to get a box plot. Create this thing. Create an array. Like give any values which you want. So you should be getting a box plot which is like this. So the reason I wanted to show you this is because you see the data 92, 75, 81, this thing, but I purposefully put one point which is like really extreme from where the mean is. I put 150 here. So in your box plot, when you see, you'll see that the median is at somewhere around 88. You will see the first quartile is here, second quartile is here. This is the interquartile range. But you will see the outlier, right? Outlier is way here. So instead of seeing this, when you look at the box plot, it'll tell you like how the distribution of the data is.
What's the point of assigning the box plot to the variable? You're not using it here.
You mean the title?
The AX.
No, so I'm not using that there. That's correct. But so the thing is, right? It needs a canvas to plot it. So this is there here, but then if you don't give plt.show, so I think maybe this is something to maybe
check the bigger ones in front of you on your left. The big ones on the back of the wall.
So basically, the plotting is like on a canvas, right? So basically, it's like a paper. So plt.show will actually show this particular canvas. But then when you're actually using Seaborn, like when you're creating that plot, it is actually putting it onto this canvas,
which is
AX. But then you need something to show that. So the thing is, since there's only one plot here, the canvas will by default like it'll show. So there is a canvas. The only thing is you can put anything on this canvas, but until you show it, you won't see that plot. So exactly. So when I created a Seaborn, when I did the thing, all these things have access to this canvas. All these libraries. When I did Seaborn.boxplot, they have access to this particular canvas. So I did Seaborn. I don't need to utilize this particular variable anywhere because by default it is actually part of the same canvas. So when I'll show you Matplotlib, you will understand. You can do subplots and stuff. That's when the canvas is shared. But in this case, it is not. So it's going to put everything on the same canvas. And when you give plt.show, that's when it'll show that. So did everyone plot this? So the way we do it is sns.boxplot and give the data points. I don't.
Seaborn S is capital.
Seaborn, sorry?
S is capital.
No. Everything is small.
Okay. Every time I get a.
So Meher, if you even remove it, you will still get the plot because it plots it on the canvas.
Okay, so what was the point of it then? Or if you have multiple canvases?
If you have if I divide it into 2-3 canvases, then I can say that this particular canvas belongs to here. If you want to put it different places, right? In different parts of your graph. I'll show you the plotting library. I thought I need to spend some time on box and violin plots because they explain more. But after this, I'll show you. We'll go through Matplotlib plots, and that time I'll show you how do you plot subgraphs, how do you make canvases and stuff. But the thing which I want you to do is whatever data you put in there, put in extreme data, like put in something like 200 or 10, which are extreme. So you create a cluster which is around 80s, and then purposefully add some data which is way. Which is basically a lot different from these things. So when you run them, so you will see that these outliers will be shown here. So now you can see that most of the concentration is here, but there are 1-2 points which are way beyond. So as I said, we have a canvas, right? You can give title to the canvas by saying plt. I just gave first box plot. You can give any name you want. But I want everyone to plot this and understand this. After you plotted this, then your next task is to now open the snowfall data which I sent you guys. So that I have Whistler and Snoqualmie, and I want you to plot two box plots, one for Whistler snowfall data and Snoqualmie snowfall data, and compare both of them. And tell me like which mountain is better to go skiing. So this is an exercise which you'll do right now. I'll show you variant plot later, but let's just do the. So you have Whistler data, you have Snoqualmie data from the thing which I showed you before.
So Sai, where am I using AX?
You're not. So basically, AX is only used for. It'll only be used if you want to place your data somewhere. Here, since it's only one plot, you will basically it by default shows. That's why I removed it. Like initially, because in general you create the plot and keep it there, and if you want to use like subplots and stuff like that, you use AX and this thing. But now you don't need to, because by default it's only one canvas. So I want you to plot the data from the mountains and then tell me which one. And first of all, compare both of them side by side. Oh, then you need to know subgraphs now. Maybe I'll just do this. You need subgraphs here. There are various other plots which you will have in. There are different plots which you will have in this thing. So you can use. But these are the main ones which we use. They're like bar plots. They're like pie charts. They're this thing. But anyway, I still didn't show you the other basic plotting ones. So I send that text file, right? Snowfall.txt. Just copy paste it. I mean, or else you can do file open, read, and everything. That'll take more time. Just copy paste the data into like two arrays here. I have the same data here.
So it's not plotting anything for me, it's only the graph is coming up, but
Did you import matplotlib.pyplot
yeah.
and add that as PLT?
I mean, the figure is popping up only with no plot. Like it's just giving me the coordinates.
So can you share your screen? Okay, before you share your screen, 1 second. I know I didn't. I rightly jumped to this box plots and this thing before. Again, for now, just copy paste this to line. I'll tell you like what this is when we in the next 5 minutes. So if you want to display two plots together, you create two subplots. Basically, the function is plt.subplot. What this tells you is it tells you like what is the height and what is the width. So when I say 1,2, that means I have like one row and have two columns. And comma 1 is the first image is where I want to plot it. So let me just quickly show you this. So when I do subplots, right? So in subplot, basically first is I'll tell you like what the height is, and then I tell you what the width is, and then I'll tell you which plot number. So plot number. So subplot, sorry. So PLT is your pyplot, right? PLT.subplot. So what this tells you is if you are giving 1 and 2, that means there are two. So this is the example. So in this case, I'm creating one row, two columns, and I want in the first one I want Whistler data. Again, the same subplot, one row, two columns. In the second one, I want the Snoqualmie data. So if you want to compare them side by side, you have to do. I'll tell you what the subplot is in like next 5 minutes. I just I quickly jumped there without telling you what plotting is. But this is just to come. So this is the first plot. So I just want you to analyze this. So if you will get the data like this, Whistler data and this thing. So both of them will be in the same plot, or else you have to pop up one and close the other. So that's why I didn't want to do that. Just I mean, even if you don't understand it, we'll cover in the next 5 minutes. But the function is basically plt.subplot. Now 1 means one row, 2 means two, like two images. The first one plot Whistler, the second one plot Snoqualmie. Oh, by the way, Deepika, since you're not from around Seattle area, Snoqualmie and Whistler are mountains which people go skiing nearby. So.
Oh yeah, I know about these places.
Oh, okay. So okay, I will stop sharing right now. Raghav, can you?
Yeah.
You can share your screen. We'll see what is happening. Okay.
For users, it's not even coming up.
No, so can you just don't give AX, just give SNS subplot. No, just close it. Why is it coming to just okay, now run it. Seaborn has no attribute box plot. Did you import Seaborn in your this thing? Okay.
Otherwise, it would show error here, right?
Yeah, it should show. But other thing is you have to give square brackets. You're creating an array, right?
Okay. Right.
I think maybe that is.
Oh God. Hopefully, I think it will run this time.
Module selects has no attribute called box plot. Let's see what if there's something different from what I've done.
Space here.
No, it is correct. It has session 2. So one thing I've generally observed is maybe it is not related to what you have, but like your data types.py has an error, right? The other file. I'm not sure if that is any.
No, this
You,
is
you don't need any. Firstly, you don't need spaces between data and points, but just trying to see why is it not finding box plot for you?
this problem. This issue is solved.
Okay.
This was working.
Oh, it still has some issue. That's why it's saying red under. But anyways, I don't think that has got anything to do with this thing. So go back to that plot. Let me see. You have points. So can you do print points before your SNS.boxplot? No, before that, I want to see if it is even. Don't think that should be the case. Print points. Okay, and now I just run it. Go up. Print points first. No, and in the console, just go up. Okay, it printed points for you. SNS.boxplot. Strange. Is anyone running into this issue? Like, is everyone able to plot the box plots?
Yes.
Okay. Can you uninstall Seaborn and install it again? I mean, at this point, I'm not sure why it is not running for you. It should find box, and it's not like a syntax error. Also, it finds what Seaborn is.
I think it would work if he can create a different project or something like that.
No, but it shouldn't. Yeah, that is there, but it shouldn't happen because why would it corrupt your environment that often?
I don't know, but it's happening very often for me too.
Oh, really?
Yeah.
It happened to me like 3 or 4 times too.
Where you're not able to override projects?
No. Before. Now
Okay.
it's fine.
So you do minus, it'll uninstall it for you. No, close it. So there's a minus there, right? So yeah, so that'll uninstall it and then you reinstall it and see. If not, I mean, I don't. That is really bad that it is happening. But if it doesn't work, then I would also like ask you to create another project. But let's see if it will work. Yeah, first one.
Oh yeah. Okay. I was thinking that as.
Yeah, install package. For others, I mean, did that subplot thing work? Were you able to display both the data together? Yeah, now try to run.
No, Sai, it did not work for me. I
Okay.
want to check your code once.
Yeah. Just
probably later. Yeah.
No, it's not finding. Okay, I think maybe create another project because I technically don't see anything wrong with the code as such. So you're importing it as SNS and you should find box plot. But I think, yeah, creating another project might be and then just install Seaborn and Matplotlib in it.
Okay.
Okay. Can you stop sharing the screen? Then I can share.
Oh yeah. Sorry.
Yeah, I don't think. Sorry. I mean, like everyone, others also you were saying, right? Like I don't see anything blatantly wrong with even the syntax or anything. So here's the thing. So for subplots, you use PLT dot subplot, and I created like one row with two columns. So 1, 2, and first image in that is Whistler data. The other one is one row, two columns, and the second image of that is Snoqualmie data. So this will give you like, and this is actually gotten from that meteorology, like the Institute of that snowfall, this thing. So it's not fabricated. So you can see the main thing which I wanted to show. You will see a plot which is like this. So okay, let me see. Let me hear your opinions. Which one do you think is better for going for skiing?
Whistler.
Why?
The median is greater than Snoqualmie.
Is that the only reason?
I mean, the outliers are even greater than the Snoqualmie. The first and third IQRs are greater than Snoqualmie.
Yes. So clearly Whistler is a better choice because one, you see that the median is, and median snowfall means like higher the snowfall, the better it is for skiers. But more than that, you see that it is basically the extremes, right? The quartile. So it is pretty much limited between 170 to like 195. But whereas here it is actually having a median of 155, but their extremities are like really like it varies up to like 175. So the interquartile ranges or even the quartiles are actually higher for this thing. So it's definitely better to go to Whistler to ski than Snoqualmie. So, but the thing is, right, if we get more data, you'll see that if there are more outliers. So the thing is, so this gives you an idea, right, like how the data is distributed, like which has a higher thing and which has higher interquartile ranges, and where are the like where is most of the like where it is most stable. So Whistler is definitely the clear choice here. So why don't we go ahead, since we're anyway in here, why don't we plot the violent plots also? So how do we plot a violent plot? It's again the same thing. We use it's the same thing. Only thing is you have to say SNS dot violent plot, and you should, the data is supposed to be given as a list. So it's an array, right? So you need to typecast it as a list and give the data. So let us do the same thing with violent plots as well. So let's create again two subplots and create a violent plot. Only difference is you have to give it as a list and then compare. You will see the difference between the violent plots now. When you actually put the violent plot, you will see how the distribution is, like how many days actually had more of snowfall around the median and stuff like that. So do the same exercise with violent plots.
And I have a question here.
Yeah.
Here you're typecasting the data as a list, but isn't it already as a list?
It's an actually you're right. I'm sorry. I thought it was an array, but we don't have arrays in Python.
Yeah, so I'm on the last one, which is the filter reachable function. So it's basically given a grammar, you have some rules that are impossible to get to.
Let me run it.
Those. Oh, right. So I wrote my implementation.
Yeah, it's already a list, so I think it should be right. It should probably. Yeah, because I just wrote it as a list because I thought it was an array, but I forgot. I told you guys there's no, everything is a list in Python. So yeah, all you need to do is then instead of box plot, just say violent plot. Just literally replace that box plot with violent plot, and you should get the violent plot. So your violent plot will look something like this.
within the symbol, which is a pair between a list of rules, where each rule is a mapping between.
So does this tell you anything different about the data?
But in the grammar, so it's the same thing, except your rules are mapping between a non-terminal symbol to this symbol type, which is like whether the type of the rules, whether terminal, non-terminal, and its value. So I don't know how to get the types. So basically, it's like it's getting the right thing, except it's not.
Somebody else talking?
Yeah. I muted him. It's. I think he's in his dorm. I think someone else is talking with it. I just muted him. So if you look at this data, right, like it'll tell you like, even though the ranges are a lot different, but it is very consistent in Snoqualmie. So if you see, like the amount of days where you actually had like 180, 160, it's actually more consistent. Whereas this actually had like only few days where it was 180, and after that, there are fewer days where it actually there's a taper here. But whereas in this thing, you will see that there are like two days where 155 and 180 has been like consistent. So this particular range, you'll have a better chance of a good this thing. Whereas in this case, it's erratic. Like it's basically not that consistent across the thing. So anyway, it is just to visualize the data to show you like it depends on your choice. Like if you feel like, oh, you're more interested in something where more number of days it is behaving like this, then you might go to Snoqualmie. But in general, higher this thing, and then higher like higher snowfall rate, and then better these things are there on Whistler. So anyway, so this is everyone understood how violent plots and box plot can help us understand the statistics of the data.
Yeah.
So let's do one other plot. It's called kernel density plot. So kernel density plot is similar to like what the violent plot is this thing, but it's like the normal curve. This thing, it'll tell you like if there are two normal curves, how like everyone understands what a normal curve is, right? Like all the distributions, like even grades and marks, everything are bell curved, they say. Bell curve means that there is one population which is close to the mean, and the rest of the population is tapered depending on the sigma and your standard deviation and variance. So kernel density plot will tell you that information. So, and it's again a very it's very simple. You just have to replace box plot and violent plot with KDE plot. So just if you replace it with KDE plot, you will get to the kernel density. Anyway, I won't talk much about kernel density plot. It's pretty much the same as what violent plots have. But I actually took the liberty to go into this box plots and stuff. But let us actually now go to the plotting basics, right? So if you go to plotting basics, so the first package Seaborn is having additional data, but the first package which actually which we learn is this matplotlib. If you actually see in this particular thing, we have matplotlib. We have taken the PLT, the pyplot. Pyplot is basically the Python plot of matplotlib, and we have extended it as PLT. So before, like we use matplotlib for basic plotting. So it's like wherever you have like histograms or scatter plots and all these are part of matplotlib. So and there, so this is different plot. Line plot is simply like when you have pandas series, where you have like only one set of data which is actually going around. You will use your line plot, and then histogram plot is obviously the number of bins, like a regular histogram, like how many a particular value and the number of bins in that particular histogram. So Seaborn, as I said, like has a much higher statistical graphics. But now let's just come to a plot. The PLT. So PyPlot is basically, it has a canvas So there are different kinds of thing in a plot. So this PLT which we have been talking about here. So this is a basic plot. So this is a canvas. Unless the main function is basically you have to say plt.show, or else that plot is not visible. You can give it a title by saying plt.title. One second. Charge. So you can give it a title by saying plt.title, and that will give you the title for that particular plot. But overall, like the other attributes of the plot. So you have x data, y data. So x data tells you the x values of the data. The y data tells you what the y values are, and then you have x label, y label. X label is the one below here. In like in this case, I actually just took patient ID as one, and then I took their age as the other. So this I think you guys should be able to do. I mean, once I finish this, so this is basically from Indian liver patients. So all I did is I took on the y-axis I plotted their age. On x-axis I just gave 1 to like 514, like the number of observations. But I said that is patient ID, like 1, 2, 3, 4. They're all patient IDs, and then the y label is basically the age of the patient. And then there are axes. So x-axis and y-axis, you can actually limit the axes. So if I don't want, if I want it to just limit itself to from 0 to 80, I will use the term x-axis and y-axis. I'll say 0 to 80, and this one, if I don't want to plot it beyond 600, I'll say 0 to 600. So you can control how big your axis should be, the height of your axis, the width of your axis. There's something called as legend. Legend is basically, let me actually enlarge this. So the legend is the thing which you see here. So that let's say if you have multiple plots, basically it will tell you like, okay, this particular thing belongs to age, and if you have like another plot in the red color, it will tell you that belongs to like something else. So that is the legend of the plot. And then what else do you have? Subplots. Subplots are what we just did, where one image I can show, I can create one subplot here and another subplot here. Subplot is the division of the plot. So in the same plot, I can actually divide it into two subplots. Markers and color. Markers are basically, the color is the color of this thing, like blue, green, this is the color. Markers are this X, and if I don't give a marker, it will look like this. But if I especially give a marker, it will point the points with X and dots and stuff like that. So that is the markers. X ticks and Y ticks. We'll deal with X ticks and Y ticks. Basically, they are like binning of the X-axis and Y-axis. We will only use them when we use histogram plots. But let's quickly actually. So now everyone understands what a plot is. How do you give the X label, Y label, X-axis, Y-axis, the legends, subplots, markers, colors. So this is a basic plot. So the function which we use for this basic plot is PLT, which is part of matplotlib. So let us do a small exercise on just plotting with different things. So let me just bring up my NumPy plots. Yeah. So this is a simple plot which I just use. So we don't use Seaborn now. So we'll just use basic matplotlib plots to plot like different. So this is a sine curve which I plotted. This is a straight linear line what I plotted. Like you can see that I gave it a legend. I gave it some by numbers. These are all like labels, and I gave the axis. I'll show you the code, but I just want to show you like different things. So this is different markers like in colors. So this is like round and red. And then if I want to show like different, like, at this stage, I can add a legend also saying the squares are something, this is a line something. So let's just quickly look at how I did it. So first thing is so to create the data, I used NumPy. So I imported NumPy. And then to create the matplotlib, and the plot is basically matplotlib.pyplot. So I think I've showed this example like first time. There is a range function which will give you like the start and end. And then this will give you the steps in that particular function. So that will give you like the range of x, and then I created a sine function by saying np.sine and at sine wave, and then plt.plot and plt.show. So if you don't show, it won't show you the canvas. Plt.plot will plot the sine wave. So that is like that's for the sine wave. And then there is another thing called linspace. That's like linearly it'll place. The only difference in that is, in this case the step was given in the end. Here it'll tell you basically from 0, I think this is 0 to 10. Yeah, sorry, again it's the same thing. From 0 to 1 it will give you like 0 to 10 it will give you 100 points, and in the other one it will give you like 0 to 1 it will give you 100 points. Here it is a step, it will tell this is the number of points. That's the only difference. Here 0 to 100 with the step of 0.01, but here it's saying 0 to 10, but you divide it into 100 points. So that's what the linspace data is. And the way you give x label, y label is saying plt.y label is this, plt.x label is this, and then you plot. And then to give a total label, right? I said that is legend. So you give label equals linear and then say plt.legend, then that label is seen. Why don't you guys plot this thing? So plot these two so that you'll get experience with like what plotting is. So here we are discussing x labels, y labels. How do we display? So plt.legend will display this thing in. So you need to give a label for it, and unless you give plt.legend, it won't show that. So you see where it is there. Like if I do this, so this is the basic sine curve. So mind you, if I don't give subplots, there's only one canvas, right? So you have to close this for the next image to open. So you see this linear here. So that is the legend, and that came because I gave it a label and then I gave it this thing. So why don't we just plot these two things? And then I'll show you how to do markers next. Just plot, just plot one of this thing, labels.
Sai, I'll be back in a couple of minutes. Looks like my son needs something.
Okay. So yeah, we're almost at the end also right now. So let me know once everyone is done with this, and I'll show some other basic plotting. Is everyone done with this? So linspace is one function. The only difference in linspace and arange is, in arange you will say what is the step you need. In linspace you will say how many points you need. So it's just complementary to each other. And the way you add legends is by using x label, y label, plots and stuff like that. So if you are done with that, the next thing is basically, so as I said, right, in plot here, since it is, here you're giving x and y, you can directly give it even as two lists. like X list and Y list. And you can give, when you're plotting, you can give like the marker here. So R stands for the red color, O is the type of marker. So instead of O, if you want cross, you will just say this and cross. X is a cross. You just have to give like the marker in this particular graph. So the thing is, right, you can plot multiple things in the same plot. So I can give a range and I can say X and Y is the same. So this will be a linear plot, and I can plot it with the marker of red color, and dash dash will give me the dots. And I can plot something like T and T squared, and blue and squared. So BS is first one is the color, second one is the type of the shape of it. B is the blue and S is the shape. And then T and T, T cube, green and this thing. So this is what it did. Like when I do this, this is the basic sine wave. This is the linear one. This is the red dots. But I plotted all of them in the same thing. So why don't you do this and add a legend for this? So let's see how you'll add the legend for. So the legend should tell you which one is linear and which is this thing. So this is a basic plot. Is everyone done with this? I mean, you need
No,
not.
Sai, just one more.
Yeah, sure. I mean, you need not complete it completely. You can do this later on also, because at least I want you to like just do the basic plotting. So I want to show you scatter plots and show you how we have computed the scatter plot from the data frame. So I'll give you like 1 more minute. Like try to do. I mean, even if you don't complete, it's fine because.
Can you scroll down a bit?
Yeah.
Thanks.
Okay, so I think rest of them we will do it later in the, I mean, as assignments and stuff. So I'll just go through. We wanted to finish plotting today so that we can start with the fresh topic next week. So the other thing, so these are like basic plotting, what the like legends are, what X labels and Y labels are. But then if you want to like, but then matplotlib basics. So there are like a lot of, as I showed you, you can do markers and stuff. And you can, like, I've showed you how to add subplots, right? You can say add subplot, and then you can give different subplots to it. But then there's something called as scatter plot. So, okay, one thing, basically we have seen how I've plotted the age, right? So instead of, so once you read the data, so I read the inpatient, Indian liver patients as into the data frame data. And then I just give the column name like data of age. So instead of X, and X will be still, for X, I'll just use a linspace, like which is 1 to 10 or something. Like I just did number of rows. So you see, I got the ages count and I just did a linspace of 1 to rows to number of rows. So that will give you like 1, 2, 3, 4, 5, 6 as with the number of rows. And in Y, I just gave data of that age, and I gave a label of this thing and a color, and then I gave a marker as X. So this will plot, remember that one I was showing you? So this will basically plot, yeah, this is the basic sine and cosine I was showing. I also plotted like, to show subplots, I plotted like these images. But this is the age of the So I did 2 subplots. One I didn't use the marker and one I used the marker. But then you can see x-axis is just the linspace, so 1 to 500. Y-axis is the patient's age. But then it's very easy to give the patient's age because, very easy to give the patient's age because I just read it into the data frame and then I put it into this thing. So that's how you actually read it from a data frame and put it, like give it as Y. And the other thing is scatter plots. Scatter plots basically, so whatever X and Y you have, just say plt.scatter and you give X and Y. So you can specify other things like area, like S equals area, and then you can see different colors. Then you will see the scatter plot. Like, remember we did a scatter plot with the bilirubin count and this thing, right? But if I want, if I want the magnitude to reflect in the dot, like let's say if this is it'll tell you, like it'll give you different colors for different plots. I mean, this is just an additional like bonus sort of a thing. Like, but we generally don't use like area and colors, but you can actually use area and colors. So area and color will tell you, it'll give you different area for different plots and different colors for different plots. So like, for example, if you have only 2 sets of data, if you give area and color, then it will plot all those things in one color and this one will be in another color. But the way we do it is called dot scatter. I mean, instead of this, I think it will be better for you to read the data from the data frame and plot the scatter plot, which I plotted for bilirubin and this thing. I'll show you how to do that. This is the other plot, which is histogram plot. So in histogram plot, the syntax is pretty much the same. So you have your X and so this is bins, right? So you have your marks distribution, and I only give the marks and I say draw a normal histogram plot and put it in 10 bins. You don't have Y in this, remember, because histograms are just bins, right? So you don't have X and Y. You have only 1D data, and you just say how many bins you want to put it in, and you just say plt.hist. You give that particular variable, give 10 bins, it'll plot the marks in 10 bins. I'll share this code with you. So, but this is like basic way of plotting different kinds of plots. So this is the histogram plot, and then you have a bar plot. So bar plot is like the same thing in this case. So let's say I have Python, C++, Java, this thing, and I have the languages, and I have number of students in each language. So you just say plt.bar, you give x-axis, which you give what you want to plot, and then you give the number of students, it'll plot that. Then ticks is basically if you want to replace. So here I created an object, right, of like different languages. So x ticks I gave as languages and objects. So what that does is it takes these languages and plots it and then gives it below. So this is a tick for this particular bar. So Python, C++, Java, and Perl appear below here. If you don't give the ticks, it will just appear as 0, 1, 2, 3. Like, I mean, there won't be labels for it. So you give that and say x ticks is this thing, and then the Y label is basically this. So that will give you like the bar plot. So, you know, like, which will give you like bars. What's the difference between bar and histogram? So bar plot is also telling you like what is, like in this case, right? Python, how many number of students taking Python, number of students taking C++, number of students taking Java. But when will you use a histogram?
If it's like the individual.
Yeah, so histogram is basically when you have marks and you want to distribute. So it's just one quantity. You don't have multiple quantities. And you want to see the distribution of that marks in different bins. So you'll use a histogram. But bar graph is exactly when you have like, you know, Python how many students, C++ how many students, Java how many students. Histogram is again used to tell you the data, right? The distribution of the data. So let's say I get the marks of like 100 students, and I want to see between 0 to 10 how many people got, between 20 to 30 how many people got, 30 to 40. So it's just one data, one nature of marks, and you put the number of bins there. So that will give you the histogram of the distribution of the marks. But the bar graph is basically going to tell you you know, like for each individual bar, for each individual bin, how many people are taking it. So that is basically the bar graph. Yeah, I did one more bar graph here. But yeah, that's pretty much the plotting. But I want you to plot. So this is like, it's just an intro to the plotting thing. So this is like, you can take two people and compare them. I'll send this code, so you'll have an idea as to like how many this thing. But the main thing I want you to do is do this exercise. So I'll tell you what this thing. So the idea is to plot male with disease and female with disease. So this is where you'll use your data structure skills I was showing you, right? Like last time. So male patients with disease and female patients with disease. And I want you to plot both of them onto one chart. And then you use scatter plots for that. So you do plt.scatter, and you give x-axis, you give the disease, and then x-axis you give the bilirubin count, and y-axis you give the alkaline phosphate count. You can give the color, the marker, and the label. And then similarly for like the female patients, you plot both of them. So ultimately it should look like this. So when I run this is the one I was showing you. So I gave male patients with disease, and I gave this as the label. And then male patients without disease, I gave this as the label. I used different markers for both of them, and then X label and Y label. So if you can plot this particular plot, then you basically understood everything, because it has the X label, Y label, it has X axis, Y axis, it has legend, and you will see how you can manipulate the data frame data into this thing. So you have the data frame, and then you get the corresponding data frame data, and then you basically show the legends and stuff like that. So this, I think I'll give you as an assignment. I'll send you this particular file also, but then don't look at the file and try to plot it yourself first. And the thing is, you can even plot box plots and scatter plots for this data. So it's not that useful because it has multi-dimensional data, but you can do violin plots and box plots for each individual X and Y for bilirubin count and alkaline phosphate count. So basically it'll look like this. So if you run this, so first is your scatter plot for male patients with disease, and the next one is your plots for female patients with disease. Oh, that's because I didn't import SNS here.
So which means we can also change the legend.
Yeah, you can change everything, whatever you want to. So
font sizes and different things.
Yeah, everything you can change. So this is how. So this one will not tell you much, because it'll tell you for each patient how his bilirubin, count and alkaline phosphate count are. But that's and then it'll show you outliers for each. It's like a lot of box plots. So I just wanted to show like you can do multiple box plots for each one in this. And similarly for violin plots, you will get violin plots. But it's mostly useful for comparing two datas together. So, but this is the assignment. So this will combine your skills of pandas data frames, your like how do you read everything. But the first thing you need to do is cleanse the data. Once you cleanse the data, then we will then we do each individual one as to like how we plot and so I'll give this thing. I didn't get a chance to do the video game sales. I'll do that next week. So there are different plots for video game sales and stuff like that. So next week, the first 15-20 minutes, I'll just do the video game sales. But I'll go through it fast, because now you know how to read it from the data frame, how you compare it to the data frame, how you do basic plotting and stuff, right? So then video game sales, I'll show you like other cool plots. They are like staggered plots, the rainbow plots. So I think I showed you in the beginning of the class. Let me show you like what is. So in this case, we've used different kind of plottings. So if I run this, you'll see like you can actually make your plotting really cool by making a gradient. So it's called a palette plot. So you see it starts off with like very light color, and then it goes to really dark. That's called the palette plot. We'll discuss this next class, but for now we'll just do this. And then there is this plot which is staggered plot. So it'll tell you the company sales of different gaming consoles. It's staggered, so you can see like who sold the most. Like there was a lot of competition between Xbox and PlayStation, so they have the most. And then in between, Nintendo actually had a huge share, but then afterwards it started dropping. So it'll tell you a lot of information about, like, in fact, I'll ask some questions on this thing. So it's a sales data, right? So most marketing folks should be doing this. And then this is basically every category-wise rainbow plot. So which category of sales was the maximum, and which year was the sales the maximum? Afterwards, who has a higher market share? So these are all the questions you can answer with data and visualization. So this is really cool kind of plots and everything, which for video game sales, I'll start next time. But everyone clear, at least understood like how plotting works and how the data processing works. What can we do with the data frames, pandas data frames? Now, all this thing is basically like all your Python knowledge and everything will come together in this particular plotting mechanism.
Yes, I had a question actually. Wanted to ask you before. We started from the ranking of the feature set, right? Which from the feature engineering.
Yes.
But in our example, while we did not actually use that ranking anywhere, we know that there are they're all independent.
No. Yeah, I mean that's because I told you, right, when I found the rank. So this is basically visualization, right? So it'll be, so the rank will tell you which features you need to plot. So first you need to get the features which are linearly independent of each other, and then the plotting and everything you will do it on top of that. So first step is anyway that, and I'll try to find the code where I did the ranking. So basically all the features are linearly independent. I don't know where I'd written it. I'm still looking for it.
I'm only trying to connect this example logically.
So step one, you have the data, right? And in the data, you first see which features are linearly independent and which are useful to you. So once you get that particular information, you will take each feature in that particular thing and do the scatter plots to see if there is variability between the features or not. So you do the scatter plot to then have an idea as to before that you need to cleanse the data. So you need to remove all the categorical objects, and you need to basically remove all the nan values or replace them with 0 or something. And then comes visualization of the features which you will be feeding it into the machine learning algorithm. So that will give you a much better idea and analysis as to how the data is distributed. Especially when we do video game sales, it'll answer a lot of questions as to which company had the highest sales, which category is actually trending, which category of first person shooter games are there more, Xbox versus PlayStation, how did it stack up according to the years? So there are a lot of questions which the data analysis will answer. So after we do all that and we have a complete understanding of how the data behaves, then we go into machine learning algorithms to see which one. So the one which I was actually telling before, right? For the bilirubin and alkaline phosphate, it seems like we can just do linearly separable models. But what will we do if it's not linearly separable? Then what are the other algorithms we will see and stuff like that? So all these things will tie up together right now. So each individual process is that clear, though? First we will do that, then we'll do this, then we'll do this. And next class, I think after covering video game sales data, we'll start with our first machine. No, I don't think we can. I have to teach R also. So actually, let me ask this question right now. So you guys are slightly familiar with Python. You've seen this thing. Should we do R and the case study with R a little later? Do you guys want to do unsupervised learning and supervised learning some algorithms and then do R, or do you want to finish learning all the languages now and then proceed?
I think R later would be preferred.
Because you're just getting familiar with Python, right?
It will be confusing too.
Yeah. So then I'll do that. So basically, in R there are two case studies. We'll do linear regression and logistic regression, and the web service which I was talking about. So what I'll do is I'll push that later. So next week, what we will do is we'll do this, and we will do a simple unsupervised learning algorithm on this data. So we'll start with k-means clustering next week, and then I'll push maybe R and linear regression and stuff. I'll push it like maybe a couple of weeks later, because I don't want to get you to get confused between Python and R. It's because it's another language, right? So I think that would be better. So yeah, so next week we'll start with unsupervised machine learning. So after finishing the video game sales data, we'll start with that. Okay, any questions?
So someone was going to set up Git or CVS, right? One of these.
Yeah, Meher will. He said he'll set up GitHub for this.
All right.
But I mean, ideally, we don't need version control because not all of us are not working on the same project. But if you want to like learn Git a little bit, then you'll set up, and then I can show you like the commands.
Yeah.
This thing. Just one thing. We won't be having a class next Sunday. This Sunday we'll have, but next Sunday there is no class. So we'll probably move that to some other day, or we'll see how we can do that, because I'm actually traveling to India.
That's 14th of October.
So 6th we have, 14th of October we won't have the class because I will be in India that time. So I don't know if I can. In fact, I'll be in India even this, but I'll be traveling on the 14th. So I'm leaving to India on the 8th. So I will take Wednesday class will be there. I'll take it from India, but 14th I will be. I think I'll be on the flight during that time. So there's no class on the 14th. So if you guys are okay, we can do that. So I just want like more of this thing. Is weekdays preferable or weekends preferable for you guys? Like, let's say if we don't do a class on Sunday, can we do that on a weekday? Like maybe we can do like Tuesday, Thursday, if that's okay. Or do you prefer doing Saturday?
I prefer weekends because I have homework during the weekdays.
Okay, so more. So if we have this thing, then you prefer it on the weekend, right?
Yeah.
Okay. So then we will probably move the class of 14th to like on the 20th or something, if everyone is okay with that. Or we can actually take an extended class on the 21st from 3 to like this thing. Depends, like let's see what everyone agrees on, or we can push it like 1 week ahead also. So is everyone okay with like weekend this thing?
Yeah. I mean, in fact, my schedule for next month is. I thought it's always going to be Wednesday and Sunday, so
Yeah,
I moved everything accordingly.
No, it is going to be Wednesday and Sunday. It's just that this Sunday we might not have a class. I mean, if we want, we can do the makeup class on the next Sunday also. Like instead of we can extend it to like 4 hours or something. It's just that I'll be in the flight that time, so I don't think I'll be able to like take a class then. So just that 14th we won't have a class.
Yeah.
Anyway, I'll send out an email. If anyone has issues, we'll try to figure out some other time, or we will see if
This idea is good. Like actually, we can extend every day by 20-30 minutes, or cover things.
yeah. No, don't worry. I'll cover everything which is there on the syllabus. Just basically, yeah. I mean, I have to go. I'm actually getting engaged. This thing. So 14th is my engagement ceremony. So,
Let's not talk about anything. First, get engaged.
yeah.
Congratulations.
Thank you. So
So-
yeah, that's
so-
why I'm able to take the class then.
Yeah, on a lighter side, you have very few days left.
It's just engagement. Marriage is in December. Yeah. Anyway, okay. So yeah. Any questions on this thing, or like I'll try to share the video as soon as possible. If no questions, then I think we're mostly done for the class.
Yeah, so I just that how to convert that CSV data into an NumPy array so that I can find the rank. That's what I was just.
Okay, I'll send it to you once the class.
Okay, yeah. Thanks, Sai.
I'll send you the code for that.
Thank you.
Okay.
Yeah. Thanks. Yeah. Bye bye.
All right. Thank you. Bye.
Thank you. Bye.